welcome back to Network Masters. In the Cisco VXLAN series day 2, we are going to perform the static VXLAN lab, which we have also called flood and learn method. Before proceeding with the lab, let me give you the brief about the lab that we are going to use in this series. So let's go to the lab. So in this lab, we are going to use two spine, spine 1 and spine 2, and three leaves, leaf 1, leaf 2, and leaf 3. And we are having two hosts connected to each leaf, and first host will be in the VLAN 10 and the other host will be in the VLAN 20. So we are doing the intra-subnet communication. So goal of our lab is to ping host in VLAN 10 to another host that are in the VLAN 10 and hosts that are in VLAN 20 to the another host that are in VLAN 20. Okay, so we are doing the intra-subnet communication. Intra-subnet communication means we will ping within VLANs. Okay. So without further ado, let's proceed. This is a new lab and I provided the hostname on all the devices. I'll be performing the lab from the sketch. So let's first start with the IP address assignment. Let's open the console of all the devices. So this is the spine 1, spine 2, leaf 1, leaf 2 and leaf 3. So in the spine 1, let's start configuring the IP address. We are going to create one loopback interface as well. So I'm going to give an IP of 1.1.1/32. Let's check the IP address. Okay, let's configure the IP address on spine 2 as well. Let's log in into the spine 2. Now Ethernet 1/2. Same IP with the leaf 4. Now last but not the least, interface Ethernet/3. Then we'll create a loopback interface 2222/32. Show IP int brief. Okay, let's configure the IP address on leaf 1. And then one loopback interface. Okay, let's proceed with the leaf 2. And then the loopback interface. And last but not the least, leaf 3. All right. So now we have configured the IP address on all the switches. Let's try to check the connectivity. So ping 1 dot ping 13 dot 1 dot 1 dot 1. I'm just checking the connectivity from leaf 1 only. 23 dot 1 dot, oh sorry, it is 23 dot 1 dot 1 dot 2. All right, great. So now we have configured the IP address on all the devices. And it seems good. So in order to proceed with the static VXLAN, we firstly need to create an underlay network for which like I'll be using the OSPF as stated earlier. So let's enable the feature on all the devices and then proceed with the configuration of OSPF. Okay, so let's come to spine 1, feature OSPF, give OSPF an ID 1 and router ID would be 1.1.1.1. Go to the interface Ethernet 1/123, IP router OSPF1, and all of them would be in area 0. IP OSPF network. I am making all the links point to point link. Exit, exit. Uh, all right. We need to do the same for interface loopback as well. So if I run the show IP OSPF neighbor, it will show nothing to me right now as uh, as we have configured no peers. So let's come to the spine 2 and enable the feature OSPF router OSPF 1, give it a router ID 2.2.2.2 and go to the interface 1/1 to 3 IP router OSPF 1 area 0 IP OSPF network point to point. Exit, exit. Let's first configure the all right, I forgot again, interface loopback 0 IP okay, this one, exit. So we have configured the OSPF on spine 2 as well. Let's go to the leaf 1 interface Ethernet 1/1. Oh sorry, let's first enable the feature OSPF router OSPF 1 and router ID would be 3.3.3.3 interface Ethernet 1/1 to 2 and IP router OSPF 1 area 0 IP OSPF network would be point to point, exit, interface loopback, and save command for loopback as well. Show CLI history unformatted, and let's look for last, I'll say 10 lines. No, 10 lines are not enough. Let's go for the 15. All right, so from here itself, let me copy these commands and paste the same on. All right, not paste the same on. Let's copy these commands because we need to change the router ID on all the devices. So um, let's enable the feature first, OSPF, router OSPF1, and router ID would be 4.4.4.4. And let's paste the configuration here. Okay, it is not getting pasted. That's okay. Uh, IP router OSPF1 area 0 IP OSPF network point to point interface loopback 0. And last but not the least, let's go for the leaf 3. Enable the feature one last time. OSPF router OSPF1 IP, sorry, let's give it a router ID 5.5.5.5 and interface Ethernet 1/1 to 2 IP router OSPF1 area should be 0 IP OSPF network point to point, exit, same config for interface loopback 0 as well. So now we have configured the OSPF on all the devices. Let's check for the OSPF neighbor. Show IP OSPF neighbors. All right. We have 333444555. 3333 is leaf 3, 4 is leaf 4, 5 is leaf 5. Let's go to the spine 2 as well. Show IP OSPF neighbor. Similar information. State is full. That's great. Show IP OSPF neighbor. Same here. show IP OSPF neighbor, and let's check on the leaf 3 as well. OSPF neighbor. All right. So it looks good now. Okay. So now we have completed the configuration for the OSPF. Now we need to create the VLAN. So in this case, in our scenario, I'm going to create VLAN 10 and VLAN 20. And once we have created the VLAN, we need to attach those VLANs to the VNI. Okay. So let's first create the VLAN. VLAN 10. Name would be VLAN 10. Exit VLAN 20. Name would be VLAN 20. Okay. So now we need to create a VNI. So for this scenario, in this case, what I'm doing for VLAN 10, I'll be creating a VNI 10, 10, 10, and for VLAN 20, I'll be creating a VNI 20, 20, 20, and I'll be mapping VNI 10 with VNI 10, 10, 10, and VLAN 20 with VNI 20, 20, 20. Sounds good? Great. Let's proceed further. Uh, let's open the console. Okay. So VLAN is created here. Let's create the VLAN on leaf 2 and leaf 3 as well. VLAN 10, name VLAN 10, VLAN 20, name VLAN 20. Similarly here on the leaf 3, configure terminal, VLAN 10, name VLAN 10, VLAN 20, name VLAN 20. Great. So now now we created the VLANs. Now we need to create the VNI and attach the VNI to VLAN. So in order to create the VNI, we firstly need to enable a feature that we called as a feature VN segment VLAN paste. All right. So now go to the VLAN 10 and tell it it is a VN segment 10 10 10. Similarly, go to the VLAN 20. You can ignore this warning. That's okay. VN segment 20 20 20 and hit exit. Similarly, we need to perform the same on all the leaf switches. So we feature VN segment LAN base and then go to the VLAN 10. VN segment would be 10 10 10, and for VLAN 20, sorry, exit. For VLAN 20, VN segment would be 20 20 20. Exit. Last but not the least, feature VN. Now for the VLAN 10, VN segment would be 10 10 10. Exit. For VLAN VN segment would be 20 20 20. Exit. All right. So now we have completed the configuration of the VNI. Let's do the config. Let's move to the last step and do the configuration for the NVE interfaces. So before doing the NVE interface configuration, let me give you a brief. So what we are basically doing, host will be a part of VLAN 10. This VLAN 10 is connected to VNI 10, 10, 10, and this VNI 10, 10, 10 would be a part of NVE virtual interface 1, which is a VXLAN tunnel interface. Okay, so whenever host 1 will try to send the packet from here to here, leaf 1 will create a tunnel between leaf 1 and leaf 2. Okay, and in order to initiate the traffic and in order to terminate the traffic, it needs an IP address. It needs a interface. So we'll be creating a NVE interface on all the leaves. Okay, and the interface name would be NVE1. All right, let's proceed further. So let's come here on the leaf 1. So in order to create the NVE interface, we firstly need to enable a feature that we called as a feature NV overlay. So let's enable the feature NV overlay. Okay, then proceed with the interface NVE1. Let's make it no shutdown, and source interface will be using the loopback 0, and I'm telling this NVE1 is this VNI 101010 is a member of NVE1 interface. Okay, so I'll be running the member VNI 101010 command, and in here I'll be doing like ingress replication protocol. So whatever the MAC address table that leaf1 has, it is going to replicate using the protocol is static. So we have two method here, BGP and static, but for this lab we are doing static, so I'll be choosing the static, and I'll be telling to leave like VNI 10.10.10 is available on which peers. So it is available on peer 4.4.4.4, and it is available on peer 5.5.5.5. Okay, hit next, hit exit, and do the same configuration for VNI 202020. So member VNI 202020. Ingress replication protocol would be static, and peer IP would be 4.4.4.4 and 5.5.5.5. Exit, exit, show running interface NVE1. So this is our configuration. We have created one NVE interface. We make it no shutdown, and it is using source interface as a loopback 0. So I'm telling VNI 10.10.10 that you will be a part of, you will be a member of NVE1. Okay, and how you are going to do the ingress replication, how you are going to perform the ingress replication. You can perform the ingress replication by via using protocol static, and on which peers. So this one is 444 and this one is 555. So on 444 and 555 we have VLAN 10, and we have already created VNI 10.10.10 on both the leaf switches. So I have told leaf 1 that if you want to send a packet to 10.10.10, you can send it on leaf, or you can send it on peer IP 4.4.4.4 and peer IP 5.5.5.5. This same configuration goes with the 202020 VNI. Great. Now let's proceed further. Do the same configuration on leaf 2 and leaf 3. So firstly we need to enable the feature NV overlay, interface NVE1, make it no shutdown, and source interface would be loopback 0, member VNI 10.10.10, ingress replication protocol would be static, and peer IP in this case would be 3.3.3 and 5.5.5. 5.5. Exit. Similarly goes for member VNI 202020. Ingress replication protocol would be static, peer IP would be 3333 and 5555. Exit. Show running interface NVE1. Alright. Last but not the least, do the same configuration on leaf 3, overlay, interface NVE1, no shutdown, source interface loopback 0, member VNI 10.10.10, ingress replication protocol would be static, peer IP would be 3333, peer IP would be 4444, exit, member VNI 202020, and do the same configuration. Alright, so now we have completed the configuration for the VXLAN. Now let's try to ping host 1 to host 3. So before proceeding with the host 1 to host 3, let me first enable host 1 and host 3. Both of them are in the VLAN 10. So let's first check the IP address. So it is 10.1.10.12. So it is 10.1.10.13. So we'll be trying to ping 10.1.10.12 to 10.1.10.13. So let me show you first the MAC address table. So if I'll exit from here, show MAC address table. As of now, uh, leaf 1 knows about the host 1. All right. So host 1 it has learned on the VLAN 10. Okay. So we have not assigned the VLANs to the port, to the leaf ports. So let's do that configuration first. So on the interface Ethernet 1/3, switch port mode access, switch port access VLAN 10, and spanning tree I'll be doing port type H, H, and make it no shutdown, exit. Similarly for the interface Ethernet 1/4, make it switch port mode access, switch port access VLAN 20. In this case it is VLAN 20, and spanning tree port type would be H, and make it no shutdown, exit. Same configuration on leaf 2. Interface Ethernet 1/3, switch port mode access, switch port access VLAN 10, spanning tree port type would be H, and make it no shutdown. Interface Ethernet 1/4, make it switch port mode access, switch port access VLAN 20, and spanning type would be port type H, and make it no shutdown, and then hit exit. So now if I'll show you on the leaf 1, show MAC address table. So now this leaf is learning the MAC address of host 1 on Ethernet 1/1. So if I'll show you the entry, if I'll highlight the entry for you, this leaf 1, is learning the MAC address of host 1 on interface Ethernet 1/3 on VLAN 10. Similarly, for the host 2 having MAC address of 8300, it is learning the entry on Ethernet 1/4 and it is on VLAN 10. Same information we have on the leaf 2 as well. So if I'll show you, show MAC address table. All right. So every leaf knows about the locally connected host. Now we'll try to ping from host 1 to host 3. So let's go to the host 1, ping 10.1.10.13. All right. Now we are able to ping from host 1 to host 3. So if I'll enable the ping here, debug IP ICMP, you will be able to see the response. So see, it is sending the replies back to the host 1. Great. Let's go to the leaf 1. Now let's check the MAC address table again. Right. Okay. So now it's working. Great. uh, let's uh, let's get this entry. Let's get this MAC address understand. Okay, so for the entry one, this one. Okay, so this is the normal behavior. Okay, so this is the host one MAC which physically received from frame on Ethernet 1/3. So learning rule is still same as it was. If frame comes locally, learn MAC and on which port it is coming. Correct. So nothing new yet. Okay, but let's talk about the another entry. Where it is? Just a sec. Let's talk about this entry. This one. Let me highlight it for you. Okay. So Lee 1 did not learn the MAC from Ethernet itself, right? It learned it from the VXLAN encapsulated packet. So this entry means host 2, oh sorry, in our case it is host 3. Host 3 lives behind VTAP 4.4.4.4. Okay, so this is the MAC address. This MAC address lives behind VTAP 4.4.4.4. So in terms of VXLAN, switch don't learn the MAC address from interface as it does in layer 2 VLAN, but it does learning from overlay tunnel source IP, which is the NVE interface. So whenever the host is trying to ping from, whenever host is sending the reply back to the host 1, so how leaf 1 is learning its MAC address, host 3 MAC address, it is putting the host 3 MAC address, host 3 MAC, and it is binding to the this IP, this tunnel IP. This is the NVE interface, which is in our case 4.4.4.4. Okay. Similarly, if I'll go to the leaf 2 and if I'll run show MAC address table, so we'll be getting learn this host getting learned via the NVE 3.3.3.3. So now leaf 2 knows whenever I whenever I need to reach out to this host 1, which is on the VTAP 1, okay, having the IP of 3.3.3.3, I'll not do the flooding. I'll simply check my MAC address table and forward accordingly. All right. So this is all for today's lab, and I hope you guys understand. Please let me know if you have any question. Please comment if you guys have any question, and thank you.